Okay, so in talking about graphing, which is our next major test, this worksheet 2.6 number 1 is going to walk you through graphing some stuff like this, 1 over x minus 3. And to be able to do that, you'd need to be able to know what 1 over x is. Would you please make a quick sketch of what that is? See if you can remember that base graph. There's 12 functions that you're supposed to know for precalc. This is one of them. In case you forgot, it looks something like that. Raise your hand if you had that one right. Okay, good. Now, of course, if I just go like plus 3, it wouldn't be that simple either. That'd be like an R1. That would move it where? Left 3. And then what if I put something out here? Now maybe it's R2 territory. It's left 3 and up 7. Okay, good. And what you're really doing is not just moving the function, you're moving its asymptotes. So the asymptote lines go here and here. And if I do this, it's going to change my asymptotes. So one of the things that we ask you to do is, on some of the problems, is just identify the vertical and horizontal asymptotes. So if this guy gets moved 3 to the left and up 7, I think you can picture that. It's going over here, and it's basically somewhere like up there. Then the asymptotes have to move with it. Okay? Now it's going to get complicated. I'm just going to get rid of all that stuff. The asymptote lines are going to have to go with it, so I'll make those in green now. They'll be up here too. But if you're asked to find horizontal and vertical asymptotes, I wouldn't go through all the trouble of graphing it just to figure it out. I would go back to Bob. Remember how Bob tells you the horizontal asymptotes? And I also gave you a dumb little way of remembering which is x and which is y. Do you remember that? The horizontal. Yes, the horizontal. It works. And now you know it's a y equals thing. And if you get them reversed, I have to mark it wrong. If you put your x's where your y's are supposed to be, even if everything else is perfect, so don't do that. The horizontal are the y ones. Okay? So if this is a y equals thing, Bob tells you y. Is this bigger on bottom, bigger on top, or same on both? It's a Bob, and it's a bigger on bottom. And here's the catch, though. Now we've grown up, and you have to put on your big boy pants now. It's not just y equals 0. It's y equals 0 plus whatever's on the outside. Because do you get that if I go plus 7, it moves a whole function up 7? Do you get that that asymptote has to move up 7 too? Okay, so you can't just say y equals 0 for Bob anymore. So I got a new name for Bob. Bob's not a 0 anymore. Bob's an outsider. Because whatever's outside the fraction, that's what it's going to be. Instead of y equals 0, now it's y equals 7. So it moves the asymptote to up 7. That's this guy right here. Okay, now the verticals, they stay the same. They're just whatever makes the denominator 0. What makes the denominator 0? X equals what? Negative 3. And you see how that's this line right? Oh, probably shouldn't bring in a new color. That's this line right there. Okay, so there's my vertical and horizontal asymptotes. Now let me ask you something. If I change this top number to 2, to me that feels like we just stretched this thing. Like if I had a 2 out in front and the 2 would go on the top, it's a lot like that, but here's the thing. Would that have changed whether it was bigger on bottom or bigger on top? Does that change my outside, and therefore does it change the 7 asymptote? No, it's still 7. So do you get how that does not change my asymptotes? A lot of people, and I included, sometimes forget that, and I think, oh, I got to double the height of that asymptote line. No, you don't. The asymptote line's not affected by this top number changing. And how about the zertical or the vertical asymptotes? The ones that are on the denominator. Do you get how this doesn't affect the denominator at all, and therefore it doesn't affect this at all? Okay, so the asymptote lines don't change a bit when you put a number on top like that. Okay, so here's one other thing that would be your friend if you had to graph this on the test. The old XY chart. I'd like you to find a few points on this XY chart. I would suggest you be smart about it. You don't put in x as negative 3, because what would that do? It would crash. You don't want to do that. So pick some numbers that work nice. Let's make this a plus 7 just to make your life a little easier so it's not quite as messy. Okay, so find some points that you know would be on this graph. Mr. B, you got any? Did you find any that worked? Okay. You put in 1. Then this would be a 1. Then the bottom would be 4. Then this would be 2/4, which would be a half. And so did you say 7.5? You would be correct. Anybody else do that? A couple people. Okay. Any other options people tried? 1 goes with 7.5. Agreed. What else? A smart thing to put in would have been x equals -2. Who figured that out? That -2 would have been smart to put in. Good job. Why is -2 smart to put in? Because watch what happens. -2 plus 3 makes what? 1, and then 2 over 1 is just 2. And then 2 plus the 7 makes 9. -2 comma 9 is on there. All right, any other points that people found? There's unlimited. It's literally infinity points that you could have said. Realistically, probably 4 or 5 that people would commonly pick. Give me another number, anything. 0, okay, if I put in 0, then if I have a 3 on the bottom, 3 plus 0 is 3, 2 over 3 is 2/3, plus 7 is 7 2/3. It's just a little hard to graph, but it can be done. Raise your hand if you had that one. Okay, good. All right, I think you get the idea. The point is that if you connect all these dots, you're going to get the idea of where this thing is. But if you just try to connect the dots and you don't know what it looks like in the first place, you'd kind of be toast. You have to know that this thing is, generally speaking, one of these graphs. And it's been moved generally where? Left 3 and up 7. So that goes left 3, up 7. Left 3, up 7. Probably go up a little higher, something like that. All right, so there's basically where the graph should be. And it's all about the asymptotes on these, where the asymptotes moved. Okay, next. Let's talk about what if they have x squared in it. Do you remember what this graph looks like? I bet a lot of you don't. Let's just take a minute here and remind you of some of the power function graphs that you were supposed to know. I would take notes on this since I saw a lot of blank looks right there. If you have x squared, x to the 4th, x to the 6th, do you remember what all those look like? They all look alike. They have all basically parabolas, and the bigger the degree is, it just gets tighter and tighter. If you wanted to make those negative, so like x to the -2, x to the -4, x to the -6, what I'd like you to think of it as is it's the same basic idea, like it has to be in the same quadrants, but asymptote lines come in. Asymptote lines come in here and here, so do you get, when asymptote lines, that you're forced to get closer and closer to them? They're sort of like a black hole. They suck the lines closer and closer to them. So then this red line isn't right anymore, but there was something in the upper right-hand corner, this line that was up in here, that line has to now go closer and closer to these asymptote lines. And the line that was in this area, that has to get closer and closer to the asymptote lines. Or you could just memorize that x to the -2 is like a volcano. However you want to memorize it, it's fine with me. But you need to know that one. Okay, next. Let's say we had x to the 3rd, x to the 5th, and x to the 7th. Those are all kind of generally what shape? The snake. Yep. Generally they look like that. Okay. What happens when they become negative? X to the -3rd, x to the -5th, x to the -7. There's asymptote lines. Asymptotes, asymptotes, and it used to be something over here, and now it can't be like it used to be. It has to be like this now. And there used to be some part down here, but it can't be like it used to be. It has to be like this now. Let me just think for a second. That does seem exactly the same as 1 over x. And it should be, shouldn't it? Because isn't that an odd number? 1 over x is x to the -1, isn't it? I'm gonna pause for. Yep, I have generally graphed it correctly. These green ones are correct for this function. Okay, and then that's all I'm going to go through on your power functions right now. I'd say the most important one that you got to keep in mind is this volcano one, x to the negative 2, which is the same as, I hope you get, 1 over x squared. Do you get that's the same exact thing as x to the negative 2? Okay. So 1 over x to the 4th would be the same as that x to the negative 4, right? Okay, so then if I asked you to graph me what's y equals 1 over x squared, we just said it 2 seconds ago, what's it look like? Volcano. What if I do this to it? Same basic thing. Why? Because it doesn't change the asymptotes. Because it's still bigger on the bottom, right? So it's still going to be Bob, which instead of, we're not going to say 0 anymore. We're going to say it's an outsider. Is there anything outside this fraction? No. So we don't have to worry about it. It's just 0. And think of it this way. What's outside the fraction? 0. So it's y equals 0. I should really teach that as Bob is an outsider instead of Bob is a 0 right from the start. It's just a little more confusing at the beginning, but it would pay off right now. All right, anyway, so the horizontal asymptotes, the Bob ones, they don't change. How about the vertical asymptotes, the thing that makes the bottom 0? See, 2 on the top doesn't make that different either. So the horizontal asymptotes here, Bob tells us it's bigger on the bottom, it's y equals 0, and the the vertical asymptotes, the zertical asymptotes, are the things that make the bottom 0, and what makes the bottom 0? 0. See how if there's a 2 on top, it doesn't affect it a bit, except if I actually am graphing it on a graphing test. The asymptotes haven't moved, they're the same spot, but the numbers might be different when I plug it into an XY chart, wouldn't they? Okay, so the line itself might be slightly different, stretchy, like it's been stretched a little bit. Let's actually graph it. If I have an asymptote here and an asymptote here and it looks like a volcano, generally it looks like this, and these 2 points used to be 1, 1 and negative 1, 1. And now would they be exactly in the same spots? No. Because if I put in a 1, here's an XY chart, with a 2 on top now, let's try putting in 1 for x. If I put in a 1, it used to be at 1, 1. Now it's going to be 2 over 1 squared, which is 1. So it's going to be 2. 1 goes with 2. Okay, so the asymptote lines didn't move, but the actual volcano is going to look a little different. It's going to be stretched up, be twice as tall as it used to be, but it still basically looks the same. Same with this side. Whatever this height was, now it's twice as big, etc. Okay, so XY chart's your friend. Don't forget that. It's really handy for the graphing test. Okay, next part. If I were to ask you, what changes did I make to this graph, and then tell me its vertical and horizontal asymptotes, okay, what changes did I make to the parent? Well, in this case, the parent is 1 over x squared, so there's really only, well, there's a couple changes. Actually, sorry, 1 over x to the 4 is the parent. So that's the parent. So then what change did I make to it? Moved it down 7. Okay, and now what about its vertical and horizontal asymptotes? Does that minus 7 affect the asymptotes? Yes. Unlike a number up here, if I'd thrown the 7 here, it wouldn't have affected the asymptote, but it does affect it out there. Would you please write the vertical and horizontals for this guy? Should be easy if you know what I'm talking about. Just make sure you know which one's the horizontal ones and which ones are the vertical ones, because if you put them in the wrong blank, I have to mark it wrong. Okay, the verticals are the zerticals, they're the x equals things. And x equals what in this case? What would make the bottom 0? 0. And horizontal asymptotes. The horizontals are the ones that Bob tells us. Bob is this bigger on the bottom? Yes, it is. Bob's an outsider, so it's y equals negative 7. Raise your hand if you had those right. Okay, good. Now we got to talk about special kind of limits. We already know how to do limits for easy ones like this. I hope you do anyway. I'm going to remind you how to do the limits for this. That one got pretty nasty up in here. Let me fix that. Okay. I'd like you to write the left and the right end limits for that. And I'm going to pause for a second while you give that a try. The left end limit starts like this. They always start like that, left or right end. Okay, I'm going to pause for a minute. You write the left and right end limits for that function. Okay, so here's what you should have said. For the left end, you should have said x approaches negative infinity, and then you should have said it approached 0. A lot of people think the answer always has to be infinity. It doesn't. Thank you. The x approaches negative infinity means I go way this way for the x, and then the other answer is this is what y is when I get there. If I go way, way, way this way, what would y be? The y of this red function would get closer and closer and closer to 0. So that's the answer. Raise your hand if you had that exact thing on your paper. All right, see, that's only half the class, so I'm a little nervous about you. Of course, some of you are sleeping right now, so wake up! Thank you. All right, I'm going to move on to this one. Limit of the function as x approaches positive infinity. That'd be way to the right. If you go way, way, way to the right, the red line approaches 0. Okay, that's supposed to be the easy stuff. Remember, this is where the y is getting close to. This is what the x is getting close to. Okay, so let's do a harder kind then. So let's say it has a vertical asymptote like this, and it's been moved a little bit. And now my graph is like this and like that. Okay, this spot right there, let's say it's 3. That's the x that it's approaching. Let's say that this spot right here, it looks a little smaller. Let's say that that's at 2. Okay, now here's my question for you. Can I approach the middle? Yes, you can. You don't know how to do it yet, but your limits can approach the middle. Instead of going way to this end and saying, where would you be? Or way to that end and saying, where would you be? Instead, you can say, where am I as I approach the middle of this graph? Here's how you'd write it. You'd say, same exact start. I told you, every time you write a limit in here, it's going to look like this. Limit of the function as x approaches whatever. And it needs an equals. Okay. And this is what x is approaching, and this is what y is approaching. Okay. If I'm approaching the middle of the graph, what x do you think I would be zeroing in on? 3. The x, this is the y-axis. Don't get confused by that. The x-axis is here. The x that I'm getting close to is 3. So it's as x approaches 3. Now, as you approach the middle of the graph, do you get that you could approach 3 from the left side, or you could approach it from the right side? There's 2 ways you could approach the 3. You could either come from over here towards the 3, closer and closer to the 3. Okay, or you could approach the 3 from the other side. You could approach from this side, get closer and closer to 3. Remember, we're talking about x. All right, so if I can approach it from either side, I have to tell you in the limit, or you have to tell me in the limit, which side you're approaching from. So if I'm approaching from the left side over here, that's where all the x's are negative. Remember, we're talking about x's here. This is where x is like negative 10 or whatever. So I'd say I'm approaching the 3 from the negatives. That is a superscript negative. It's a raised up negative. Okay, that's approaching the 3 from the negatives. Now, if I approach the 3 from the negatives, that means I'm getting closer and closer to the 3, coming from over here. I'm getting closer and closer to 3. You're going to end up jumping onto one of these tracks. It's like they're little railroad tracks. And did you hear about New York where that train was going around the corner? Went around the corner too fast, went around the corner at 80 miles an hour, and so it flipped over and derailed, and like 4 people died and everything. So anyway, made me think of train tracks. So I'm going to be going and jumping on these tracks right here and going around this corner, hopefully not at 80 miles an hour. And now I'm heading down, and do you see if I keep going, I'm going to eventually go to negative infinity. So the answer for that, if I approach 3, then my y, which is what they want right here, the y would be negative infinity. Okay, if I were to take the same graph and was asked for the right, to approach from the right side, that'd be lim of the function as x approaches 3 from the right side, which means instead of from the negatives, it's from the positives. A little raised up plus right there. That's a superscript plus. Should be writing this down. Stay with me. It'll help you. Stay with me. And then it equals, well, when I approach the 3 from this side, I'm going to jump on that track right there. And it's going to force me up to positive infinity. All right, the only way to actually learn these is to try them. So I'm going to give you one, and I want you to write me the inside limits, I'm going to call it. Where the limits, and the way they usually say it in the directions, is the limits as the function approaches its vertical asymptote. Because see, this is the vertical asymptote right there. The limits as the function approaches its vertical asymptotes. Very long title for this problem in your notes. It's the limits of as the function approaches its vertical asymptote. All right, so here's another one. Except this time the vertical asymptote's over here. And my function looks like this, except it's now an upside down volcano. All right. Now I want you to tell me if this spot right here is at -8 and the height of this thing is at 4, then what is the limit of this function as x approaches 8 from the negatives? And I'd like you to tell me what's the limit of this function as x approaches 8 from the positives. Give it a shot. Here's what you should have said. The limit of this function as x approaches -8 from the negatives means I was over here in the negatives walking around, and then all of a sudden I was forced to get closer and closer to 8. So I'd come from over here, and I'm going to get closer and closer to 8, and I would get sucked into this track, and then I'd go around the corner, and I'd head down to negative infinity. Raise your hand if you had that one correct. Okay, good. And then if I'm approaching the 8 from the right side, it means I was over here in the positive numbers, and I was all of a sudden sucked into the vortex, and I'd head down to also negative infinity. Raise your hand if you had that one right. Okay, good. I think you're getting it. Remember to look for the limits as it approaches its vertical asymptote. That means you're going towards the middle. End limits are the kind where you're going to the way right or the way left. Those are called the end limits. Yes, ma'am. Hand, please. Yes? Oh, yes. That's a good point. This is approaching -8 from the negatives. Thank you. That's not supposed to be a positive 8. That was supposed to be a -8. See? Good catch. Thank you. Anybody else have a question, comments? Yes?
So we don't have to write superscripts for end limits?
If you're doing end limits, you would not have to write a superscript. Safe statement, yes. Because you're always approaching positive infinity or negative infinity then. And the superscripts are always going to happen in here. And if you're going on an end limit, you're going to always be a positive infinity or negative infinity. Okay, so, lots to know. I think I've covered everything that we have to have for this worksheet, so I'd like to hand it out to you and get through the first couple problems with you. Not getting to those yet. Okay. Numero uno. Number 1 says, describe how the graph can be obtained by transforming this graph, 1 over x. So in other words, on number 1, describe the difference between it and 1 over x. You just have to move it, what? Right 3 is correct. Because it looks like this. And so, yeah, that just moves right 3. That's how it can be obtained by transforming the parent. Identify the horizontal and vertical asymptotes. Write them this way, HA, VA. And the HAs, don't get these confused now. The horizontals are the horizontals, the y equals things, and the verticals are the zerticals, the x equals things. And the horizontals, Bob tells you, is this a bigger on bottom, bigger on top, same on both? Bigger on the bottom, and now we know Bob is not just a 0, he's an outsider. Is there anything on the outside? And therefore it's just 0. And the vertical asymptotes, the verticals, the zerticals, the x equals things, they're on the bottom. What makes the bottom 0? So therefore it's x equals 3. And if you had to graph it, that's how I would start, is graph your asymptotes lines in there, but we don't have to graph these. Use limits to describe the end behavior around the vertical asymptotes. Oh, that's that kind where they're middle limits. I would make a quick sketch of this thing. It's got a vertical, y equals 0 and x equals 3. Here's x equals 3, y equals 0. It looks basically like that. Now I got my little sketch. Only took a second. And now I could make my limits around the asymptote. Lim of the function as x approaches. Where's my vertical asymptote? It's right here. What is it? 3. X approaches 3. And now you have to remember that you're approaching it either from the negatives or the positives. So I'm going to approach from the negatives. And you could have done positives. It'd be fine. I'm approaching from the negatives over here. And I'm going to go down to negative infinity. Then you do the exact same thing except approach from the right. This is from the left. You do not have to label this. I'm just labeling it for people that are learning how to do it right now. And to do it from the right, lim of the function as x approaches 3 from the positives equals. And if I approach from the positives, I'm over here. And I get closer and closer. I get sucked into that line, and then I am forced way up there. Positive infinity. Any other things they want me to do? Yeah, use limits to describe the end behavior. So I got to write another set of limits. Holy cow. So I got to write 2 more limits now. Lim of the function as x approaches infinity. That'd be the way right. If I go way right, this thing would get closer and closer to 0. And the lim of the function as x approaches negative infinity would be, that's way left. And it's going to get closer and closer. If I go way left, the height is going to be 0. Okay. That's all stuff you have to do for problems, for problem 1. Problem 2 is a lot alike. It's just that they're the volcano functions. That's the only difference. Problems 3, 4, 5, and 6, they're just volcano functions to start with. All right, on the other side. On these, it's way easier because they already wrote out the lim for you. So 7, 8, 9, 10, 11, 12, 13, 14 are super simple because they've already written out the limit. You just have to say equals what? So you actually have to finish their limit statement. And we apologize that they're written slightly wrong because it says x arrow 3. That's supposed to be underneath the lim, but we couldn't make the computer do it that way. There's no software that allows us to write the x arrow 3 underneath the lim. You have to when you write your answers because you won't be using a computer. All right, so all you need on those is equals 0 or equals infinity or equals -2. So those are super simple answers, 7 through 14. 15, 16, 17, and 18, it says find the horizontals and verticals. Ask Bob. Remember, Bob's an outsider now. And the verticals, those are always the things that make the bottom 0 for the verticals, the zerticals, the x equals things. All right, I think you've got all you need to be able to answer these now. The main new thing for today was that limits that go towards the middle are limits that approach for a function as it approaches its vertical asymptote.